Ooh, sorry guys, there's a bump right at the beginning there. So we're going to talk tonight about Chapter 2, Key Issue 2, which is Why is Global Population Rising? And this is actually a really important section because it deals with crude birth rate, crude death rate, natural increase rate, things like that. And these are things that are going to be really important when we're looking at different cultures, different countries, and this is going to come up in pretty much every unit from now on. So it's important that we get a good basic understanding of this in this excuse me, in this unit. So geographers measure population change in a country or the world as a whole by using these three measures. So crude birth rate, as you learned last night when you did your dirt, is the total number of live births in a year for every 1,000 people alive in the society. So you take the number of live births and you divide that by the number, by every 1,000 people alive in that society. Conversely, the crude death rate is a total number of deaths in every year for 1,000 people alive in society. Then the natural increase rate, or the NIR, is the percentage by which a population grows in a year. So how you determine that is you take the CBR and you subtract the CDR and you get the natural increase rate. So you have your number of live births divided by 1,000 people alive in society, your total number of deaths in a year for every 1,000 people alive in society, and you get your natural increase rate. So remember that your NIR is a percentage. So remember that, so that that's the N per 100, while the CBR and the CR are expressed as N per 1,000. So you have to be really aware of the numbers that you're using as you're doing that. Okay, so let me scooch forward a little bit, see if we can see that. I don't know about you. My eyes are really old. I can't see that at all. Can you see it? Just looks like a big blur on my screen. So what we're looking at in this graph is the population in billions, and this is going to be the world, because obviously it's lots. So we have the population in billions starting at 0 in the year 8000 BC, and as it's gradually, or not gradually, increasing from the year 2012, and how that population is growing and how that huge increase that we have. So it tells us the different eras and the NIR, or the national, or the natural, sorry, not national, the natural increase rate. Sorry, let me zoom out again. The natural increase rate. And then the doubling time. And so that's the number of years it takes for the population to double. So we see that the population in 2012 is 7,037,000,000. Okay, so the natural increase is our next component. There are about 82 million people which are added to the population of the world annually. And the rate of natural increase affects the doubling time. So that's what we just looked at on that last graph, what the doubling time was. So the doubling time is the number of years needed to double the population, assuming a constant rate of natural increase. So in the 21st century, the rate was 1.2%, and it took 52 years for the population to double. So the global population in 2100 will reach 24 billion if we have this, if the doubling rate stays, if the natural increase rate stays constant, and that's what the doubling time will be. So in 1963, the the rate was 2.2, and it took 35 years for the population to double. So the global population in 2010 would have been 10 billion instead of 7 billion. So obviously what that tells us is population rate has slowed down a bit. So more than 95% of the natural increase is clustered in developing countries. And that makes sense, particularly given what we learned about birth control, and what we learned about education involved in birth control, and what we've learned about religious issues involved with birth control, and government involvement in birth control. So developing countries don't have as much involvement in those issues, and we'll talk more about that. Okay, so if we look at the legend on this map, it tells us that tells us the world natural increase percentage per year. So the darker the country, the higher natural increase. And so you can see that countries in Africa, and then Central America, and the Middle East, and then we've got Pakistan, and then over in, it looks like, Vietnam, and in not Papua New Guinea, but New Guinea have higher levels of natural increase. Okay, so let's look at fertility. The total fertility rate is the TFR. This is the measure used by geographers to measure the number of births in a society. So it's defined as the average number of children a woman will have throughout her childbearing years. And your childbearing years are 15 through 49 generally. Obviously, there are some people who have children younger than that, and some people who have children older than that. But this is the generalized time when people have children. And the TFR for the world is 2.5. So that is the average number of children in the world. It exceeds 5, however, in sub-Saharan Africa, and 2 or less in nearly all European countries. So remember, the TFR for the world is 2.5, which is the average. Higher than that in sub-Saharan Africa, lower than that in nearly all European countries. Okay, so again, let's look at, our next component is mortality. And the infant mortality rate is the IMR. This is a measure used by geographers to better understand death rates in a society. And this is the annual number of deaths of infants. And infants are qualified as babies under the age of 1 year. And this is compared to total live births. So this is all the babies born, and then those that pass away before 1 year of age. And this is usually expressed per 1,000 births rather than as a percentage. And the infant mortality rate is 5 in developed countries and 80 in sub-Saharan Africa. So that tells you how significant that infant mortality rate is in sub-Saharan Africa. So this map shows us the crude birth rate per 1,000. And again, the darker the color, the higher the crude birth rate. And remember, our crude birth rate is the total number of live births in a year for every 1,000 people born alive in this society. So this tells us that the darker purple the countries, the more babies are being born per people in that society. So once again, sub-Saharan Africa is definitely affected, and countries in the Middle East are more affected by that. And then we see countries in Europe are less affected by that. Okay, and then this is children per childbearing years per woman. And so if we look at, hold on just a second, we've got an argument over here. We've got 6 pounds of fury versus 13 pounds of why are you barking at me? Birdie, Birdie, no. Okay, so children per childbearing years per woman. So the darkest orange is 4 and above, and we see again, this is mostly Africa, some in the Middle East, some in Southern Asia, and then it gets lower and lower until this is the below 2 range, which is really the Western world, most of Europe, Australia, etc. Okay, so let's look at the summary of the spatial patterns that we've just talked about. In developed countries, we have lower rates of natural increase, crude birth, total fertility, and infant mortality. And in developing countries, we have higher rates of natural increase, crude birth, total fertility, and infant mortality. So again, here's the crude death rate. So this is deaths per 1,000 people, and the darker the color is 15 and above. So 15 people per 1,000 people alive are dying per year. Okay, so the next thing that we're going to look at is population pyramids. So let's look at the population structure. Fertility and mortality vary not only spatially, but also temporally within a country. And a special bar graph known as a population pyramid can visually display a country's distinctive population structure. So on the x-axis of this population pyramid, so this is what they look like. So on the x-axis, of the population pyramid, we're going to have the percent male displayed to the left of the 0 and the percent female displayed to the right of the 0. So the percent male is generally shown in blue, which is helpful, and the percent female is generally shown in red. So we can see on these maps in the United States, we have, if we look up here, we have more females than males. In Kansas, like they have more old women than old men. Look right here. We have more girls between the ages of 5 and 9 than boys. And Laredo, Texas, we have more older women than older men. Okay. So that's the x-axis. Then the y-axis groups what are called age cohorts. These are typically grouped in 5-year intervals, and the youngest are displayed at the bottom and the oldest at the top. So I started to show you those already. So down at the bottom here, we have, that's the x. On the y-axis, we have age cohorts. And this is 0 to 4, 5 to 9, 10 to 14, 15 to 19, etc., all the way up to 85. So down here, you're looking at the percentage of the population, and up here, you're looking at the age of the people. Okay, so the dependency ratio is defined as the number of people who are too young or too old to work. And that's compared to the number of people in their productive years. So the people who are dependent on society are people who are 0 to 14 and over 65. These are the dependents. And if you have a larger dependency ratio, the implication is that you have a greater financial burden on the working class. So the dependency ratio in sub-Saharan Africa is 85% because they have more children. And then in Europe, the dependency ratio is only 45%. So in sub-Saharan Africa, there's a larger or a greater financial burden placed on the working class than in Europe. So let's go back and look at that on the population pyramids. Sorry, it's not looking very focused. Focus. It just looks closer up, but blurry. Okay, hopefully that's a little better. So, below the age of 14, all these people are dependents. And above the age of 65, all these people are dependents. So the higher that number, so for example, look right here. Look at how many people in Naples, Florida are dependents. They have less kiddos, but they have more elderly. Then in Laredo, they have tons of kids, less elderly. So you're balancing that out. You know, Naples and Laredo have almost not exactly opposite population pyramids because the middles are somewhat different, but you're looking at, you know, oh, Laredo doesn't have that many elderly people, but they have so many young people, whereas Naples doesn't have that many young people, but it has so many elderly people. So that dependency ratio is you have to look at both the young people and the elderly people. Lawrence, Texas has a really nice dependency ratio because they don't have that many young people. They also don't have that many elderly people. They have a lot of people in the middle here who are working and making money. Okay, the next thing that a population pyramid shows us is the sex ratio. And this is the number of males per females in the population. Developed countries tend to have more females than males, and this is because females live 7 years longer. So once again, all the ones that we looked at here, we saw that there are more females than males, more females than males, more females than males, more females than males. Okay, so what countries are not going to have more females than males? Obviously China, right? Most likely India. Countries where women are not valued, they're not generally going to have more females than males because there are going to be ways that people do not keep female babies, and thus the female population is not going to be as high. Now that's going to end up causing problems later on for that society, as we talked about that causing issues for China today. There are problems for marriages later when you have a huge male population. So what will happen is you have lots of male babies, which causes a huge male population here. So look right here, look at this huge, okay, so imagine this were real small. You have a huge male population, a small female population. That means there are going to be males who can't get married, which is going to cause problems later. So as this population pyramid, if it were to be scooted up, and these males are not finding wives, that means there aren't going to be as many babies later on. So you have to be able to take these population pyramids and think about, given what I have right now, what would this pyramid look like in the future? So if I have lots of males here, few females, then later on as it scooches up, we're going to have problems with the number of babies because people aren't going to be able to get married and have more children. And that's something, remember, we saw today that the Chinese government was really trying to advertise and encourage people to keep their female children, but because in society it was more important and more valuable to have male children, they were not able to combat that effectively. And I think, oh, so here's just a map of that sex ratio. So if we look here, where it is this kind of blue-purple, there are more men than women. So look at those countries. It's really interesting to see. I mean, it's not interesting. It's kind of obvious in some places. So China, India, the Middle East, Northern Africa, it seems to make sense that there are going to be more men than women. But then there are other places where it's about the same. Lots of places in Africa, in South America. But then where it's purple, there are more women than men. So more of your developed countries have more women than men. And it's a good time to point out that we're using the terms developed and developing. So notice that the terms first and third world are not really okay to be used anymore. You know, those are terms that were more appropriate during the Cold War, but today they're not really appropriate. So what we use are developed and developing, and I can't remember if those, I know that I didn't talk about that in any of the previous videos, but I want to make sure that that's something that you're aware of. So first world and third world are not appropriate, but developed and developing are. Okay, so that's it for tonight, and I'll see you guys later.